March 17, 1943, Rechlin Experimental Airfield, Germany. The pilot's hand trembled slightly as Hans Vera Leischer entered the first notation in his logbook, recording an event that would fundamentally alter Luftwaffe understanding of their enemy. The Americans cannot possibly have built thousands of these machines. No nation could manufacture such complexity on an industrial scale while fighting a global war. Through the cockpit window of the captured Boeing B-17 Flying Fortress coded DL+XXC by German forces, Leischer studied an instrument panel that contradicted 3 years of Luftwaffe intelligence assessments. 13 defensive gun positions would eventually surround the most advanced variants of this aircraft. The B-7F model before him carried 9 heavy-caliber machine guns, each capable of firing 750 rounds per minute, creating an interlocking field of fire that transformed the bomber into something unprecedented in aerial warfare. In German hands, this captured fortress, nicknamed Wolfhound, represented the first intact American heavy bomber the Luftwaffe would test fly. What Leischer and his fellow test pilots would discover in the months ahead would prove more devastating to German confidence than any battlefield defeat. The firepower concentrated in this single aircraft, when multiplied across hundreds of bombers flying in defensive formations, created a level of aerial combat capability that German fighter pilots had never encountered and German industry could never match. The transformation from enemy weapon to intelligence. Goldmine had begun 3 months earlier on December 12, 1942. Lieutenant Paul Flickinger piloted B-17F serial number 4124585 call sign Pub during a bombing run against the Rouen-Sauterville Railroad marshalling yards in occupied France. His aircraft, part of the 361st Bombardment Squadron of the 303rd Bombardment Group stationed at RAF Molesworth in Huntingdonshire, England, carried the unofficial name Wolfhound, painted on its nose by the American ground crew. The 3003rd Bomb Group, known as Hell's Angels, had received its baptism of fire nearly a month earlier, but still lacked extensive combat experience. On this December morning, the group furnished 20 B-17s for a mission targeting Luftwaffe servicing facilities some 60 minutes east of Paris. The mission started routinely enough, but German fighters from multiple Luftwaffe units had other plans for the American formation. Messmid Bf-109s and Focke-Wulf FW-190s attacked the American formation with aggressive persistence. German pilots pressed their attacks with determination, understanding that breaking up the tight defensive formations offered their best chance of success. Machine gun and cannon fire tore through Wolfhound's fuselage and wings. One engine sputtered and died, its propeller windmilling uselessly. Another began losing power, smoke trailing from damaged cylinders. Flickinger faced an impossible choice. Ash's crippled bomber fell behind the protective formation. The other B-17s continued toward England, unable to slow down without making themselves vulnerable to the swarming German fighters. Attempting to reach England across the Channel meant certain death for a damaged bomber unable to maintain formation, heading for neutral Switzerland, or Sweden involved hundreds of miles over hostile territory with failing engines and pursuing fighters. The only option that offered his crew any chance of survival was an immediate emergency landing on enemy-controlled soil. Scanning the landscape below through breaks in the clouds and smoke from his damaged engines, Flickinger spotted what appeared to be a suitable field near Melun, France, approximately 60 mirrors southeast of Paris. With remarkable skill, considering his aircraft's damage, he brought the massive 30-ton bomber down for a wheels-up landing in a hayfield. The B-17 slid across the grass and mud, its ball turret guns pointing downward, plowing a long furrow before coming to rest. The 10-man crew emerged from the aircraft with hands raised, expecting to become prisoners of war. What they didn't expect was how valuable their intact aircraft would become to German intelligence. Within hours, Luftwaffe ground crews and Wehrmacht soldiers swarmed over the captured fortress. Engineers photographed every system, every structural detail, every technological feature before the bomber could be damaged by souvenir hunters or sabotage. The bomber represented an intelligence windfall beyond anything previously captured. Most downed Allied aircraft arrived in pieces, scattered across fields and forests, their secrets buried in twisted metal and broken components. But Wolfhound sat nearly intact in a French field, a complete example of American heavy bomber technology ready for exploitation. German recovery specialists immediately recognized the prize before them. This was not just another crashed bomber tobe stripped for scrap metal. This was the first B-17 flying fortress to fall into Luftwaffe hands in flyable condition. The capture represented an unprecedented opportunity to study American heavy bomber design, construction methods, defensive armament, and operational capabilities. German technicians worked quickly to transport the damaged but repairable bomber to Leeuwarden Airfield in the Netherlands, a major Luftwaffe base that had been developed from a pre-war Dutch civil airport. The transportation process required careful planning and execution to prevent further damage to the valuable prize. 2 days after capture on December 14, 1942, German mechanics completed temporary repairs to the battle damage. Fuel tanks were topped off with German aviation gasoline. German national insignia replaced American markings on the wings and fuselage. Large black crosses adorned the wings. A swastika marked the tail, and the distinctive hellish red and black colors of Nazi Germany announced the bombers' new ownership. 2 Messerschmitt Bf-10 heavy fighters took position as escorts, and a hand-picked German crew climbed aboard for the ferry flight to Rechlin, the Luftwaffe's premier testing and evaluation center located approximately 50 bar-mirrors north of Berlin in Mecklenburg. The flight plan was distributed to every Luftwaffe fighter base and flak battery along the route with explicit instructions not to engage the captured fortress. But despite these precautions and the clear German markings, some Luftwaffe forces fired on their own captured prize, inflicting minor additional damage before recognition signals could be confirmed and the attackers called off. The incident highlighted both the German eagerness to destroy American bombers on site and the difficulty of coordinating operations across fractured command structures in a military organization that was beginning to feel the strain of fighting on multiple fronts. When Wolfhound touched down at Rechlin after its circuitous flight from the Netherlands, it entered a world dedicated to understanding enemy technology. Rechlin served as the central testing facility for all Luftwaffe aircraft evaluation. A German equivalent to the United States, right? Field in Ohio or the British Royal Aircraft Establishment at Farnborough. Every captured Allied airplane that could be repaired to flying condition eventually made its way to this secretive base. Here, German engineers dissected foreign technology, searching for weaknesses to exploit and innovations to copy or counter. The facility employed hundreds of technicians, engineers, test pilots, and support personnel dedicated to the single mission of understanding how enemy aircraft worked and how to defeat them. For 3 months following its arrival in mid-December 1942, Wolfhound remained grounded while teams of specialists conducted exhaustive examination. Engineers removed panels to study structural design, marveling at the sophisticated stressed skin construction that gave the B-17 its legendary toughness. They measured skin thickness, analyzed alloy composition, tested rivet patterns and joining techniques. Every system received detailed documentation. The electrical network with its miles of wiring revealed American approaches to aircraft systems integration. The hydraulic controls showed sophisticated valve designs and pressure regulation. The oxygen distribution system demonstrated American understanding of high-altitude operations. The intercom system provided clear communication despite engine noise. The fuel management system allowed pilots to shift fuel between tanks to maintain proper center of gravity. The engine synchronization system reduced pilot workload while maximizing performance. Each component was photographed from multiple angles, sketched in detailed technical drawings, measured with precision instruments, and compared to equivalent German systems. Luftwaffe aeronautical engineers marveled at aspects of American manufacturing philosophy revealed in the B-7's construction. The bomber demonstrated mass production techniques on a scale German industry had never achieved or even seriously attempted. Standardized components meant parts manufactured at different factories would fit together without custom fitting. Interchangeable parts allowed damaged components to be swapped quickly in field conditions. Simplified assembly sequences reduced the skill level required for workers, allowing semi-skilled labor to build complex aircraft. Everything about the bomber's design indicated an industrial philosophy fundamentally different from German practice. Where German aircraft required skilled craftsmen to hand-fit complex components through labor-intensive processes, American bombers used standardized modules that semi-skilled workers could install rapidly using jigs, templates, and fixtures. The implications were staggering for German planners who understood industrial capacity. If one captured bomber showed this level of manufacturing sophistication, suggesting an industrial system optimized for volume production. How many could American industry produce in a month and a year? The numbers, when German intelligence analysts ran the calculations, suggested production rates that seemed impossible, yet proved conservative. On March 17, 1943, Wolfhound finally took to German skies for its first flight under Luftwaffe control. Flugführer, an experienced Luftwaffe test pilot selected for his skill and judgment, conducted the maiden flight from Rechlin. The bomber handled smoothly despite its size, responding to control inputs with surprising docility. American pilots had consistently praised the B-7's flight characteristics in reports that German intelligence had intercepted or obtained through prisoner interrogations, and German test pilots quickly confirmed these assessments through direct experience. The Fortress flew with surprising stability for such a large aircraft, weighing 15 tons empty and up to 30 tons fully loaded. Control responses felt predictable and balanced across the entire flight envelope. Even with one or two engines shut down during deliberate single-engine and twin-engine tests, the bomber maintained controllable flight, a capability that explained why so many damaged B-7s managed to return to England after sustaining terrible combat damage that would have doomed German bombers. Over subsequent weeks throughout the spring of 1943, multiple German pilots flew Wolfhound in varied test profiles designed to explore every aspect of the aircraft's performance and handling characteristics. High-altitude performance evaluation showed the bomber could operate comfortably above 25,000 ft, where German anti-aircraft artillery became progressively less effective due to reduced projectile velocity and longer time of flight. Engine synchronization tests revealed sophisticated propeller control systems featuring constant speed propellers and automated governors that reduced pilot workload while maintaining optimal engine performance across different flight regimes. Formation flying exercises demonstrated the bomber's stability in close proximity to other aircraft, explaining how Americans maintained those tight defensive box formations that Luftwaffe fighters found so difficult to penetrate without exposing themselves to concentrated defensive fire. The B-7's flight characteristics made it an ideal platform for the demanding task of formation bombing, where dozens of aircraft had to fly in precise geometric patterns while under fire. But the tests that would prove most significant to German fighter tactics involved the defensive armament. Understanding the B-17's weapons suite became the highest priority for Luftwaffe. Tactical planners across all fighter units in the West, every German fighter pilot needed to know the Fortress's blind spots, the angles of approach that offered the best chance of survival, the ranges where German cannons could strike without entering the lethal envelope of American machine guns, and the tactics that experienced pilots had developed through costly trial and error in actual combat. The numbers alone were sobering to German planners who understood the implications. The B-17F model carried 9 Browning M2 machine guns of .050 caliber positioned to provide overlapping fields of fire across nearly every approach angle a fighter might use. Later models, particularly the B-17G that would enter service in summer and fall 1943, would increase this to 13 guns through the addition of a chin turret and improved nose armorament. But even 9 heavy machine guns represented firepower exceeding anything German bomber designs incorporated for defensive purposes. German bombers relied on defensive gun positions that were often improvised, cramped and limited in traverse angles. The Heinkel He 1111, the Luftwaffe's standard medium bomber, typically carried 6 or 7 machine guns of mixed caliber, many of them rifle caliber 7.92 mm weapons with limited effectiveness against attacking fighters. The Junkers J-88 fast bomber might have 4 or 5 defensive positions scattered around the airframe, but an American B-17F carried 9 heavy machine guns as standard equipment, and every round fired was a .50 caliber projectile capable of penetrating armor plate, destroying engines, shattering canopies, and killing pilots from ranges exceeding 600 UED. The No. 50 BMG cartridge fired by these weapons delivered 3 times the kinetic energy of German 7.92 mm rounds and comparable energy to German 13mm heavy machine guns. Hans Vera Lehr, who would become the most experienced test pilot of captured Allied aircraft during the war, flew Wolfhound extensively during the spring and summer of 1943. His post-war memoir, published decades later under the title Luftwaffe Test Pilot, Flying Captured Allied Aircraft of World War II, provided detailed accounts of his experiences with the bomber and numerous other Allied types. Lurzer approached captured aircraft with scientific curiosity rather than ideological prejudice, a professional attitude that made him invaluable to the Luftwaffe's evaluation program. His engineering background from university studies combined with exceptional natural flying ability, developed through years of glider flying and powered aircraft experience, made him ideally suited for the demanding and dangerous work of test flying enemy aircraft. He flew over 125 different aircraft types during the war without a single serious crash or damage incident, a remarkable safety record that testified to both technical skill and careful methodology in approaching unfamiliar aircraft. When Lears climbed into Wolfhound's cockpit for his first flight in the captured bomber, he had no instruction manual, no training program, no checklist, no qualified instructor to provide guidance. He learned by observation and experimentation, studying the controls and instruments, making educated guesses about function and operation, and carefully testing his assumptions at altitude, where mistakes wouldn't prove immediately fatal. The instrument layout differed significantly from German practice in both arrangement and philosophy. American designers favored centralized panels with standardized gauge positions that remained consistent across different aircraft types, allowing pilots to transition between aircraft more easily. Circuit breakers replaced fuses in the electrical system, providing resettable protection that simplified troubleshooting and maintenance. Hydraulic pressure indicators used different pressure scales, calibrated in pounds per square in rather than kilog per square sim. The throttle quadrant operated with reversed logic compared to German aircraft with forward motion, increasing power rather than decreasing it. But perhaps most impressive to Lurch was the bomber's sheer robustness and damage tolerance. The B-17 absorbed punishment that would have destroyed equivalent German aircraft, continuing to fly and fight after sustaining damage that seemed unsurvivable. Its structural strength came from heavy-gauge aluminum alloy frames and stressed skin construction that distributed loads efficiently across the entire airframe. Multiple redundant systems meant single failures rarely proved catastrophic to the mission. Self-sealing fuel tanks prevented fires from small-caliber hits, a technology the Germans understood but had never implemented as comprehensively. Armor. Plate protected critical crew positions and vital systems with particular attention to protecting the pilots, engines, and fuel system. Lurzer and other test pilots at Dublin conducted numerous firing tests to understand the B-7's defensive capabilities from the attacker's perspective, the viewpoint that mattered most to German fighter pilots who would face these bombers in combat. German fighter pilots would climb into Messed Bf-109s and Fowler-Wolf FW-190s, then make simulated attack runs on Wolfhound while it flew straight and level or performed evasive maneuvers. Ground observers photographed the engagements and recorded angles, ranges, closure rates, and exposure times. Combat cameramen filmed the exercises from chase planes, creating training footage that could be shown to fighter squadrons across Germany and occupied Europe. These exercises revealed uncomfortable truths that contradicted pre-war assumptions about bomber vulnerability. Attacking from directly behind. The traditional German approach to bomber interception that had worked well against earlier Allied bombers with limited defensive armament exposed the fighter pilot to the most concentrated defensive fire the B-7 could deliver. The tail gunner position, enclosed in a powered Cheyenne turret with excellent visibility through clear plexiglass panels, commanded a clear field of fire directly after with no blind spots above, below, or to either side within 30 degrees of the tail axis. The dorsal turret, a Sperry design mounting 250 caliber guns and a powered rotating turret, could swing rearward to add its firepower to the defensive barrage, doubling the number of guns engaging a rear attacker. Even the waist gunners standing at open windows along the fuselage midsection could engage targets approaching from behind and slightly below or to the sides. A fighter pilot boring in from 6 directly behind the bomber faced at least 4 heavy machine guns concentrating fire along a predictable intercept path. The tail gunner alone could bring 2 guns to bear, and if he was skilled and the range was appropriate, his fire could be devastating to the thin-skinned fighter aircraft. The closing speed between attacking fighter and fleeing bomber, typically around 150 to 200 mph differential, gave the German pilot perhaps 3 to 5 seconds of firing time before breaking away to avoid collision with the massive bomber. During those few seconds, the bomber's gunners poured hundreds of rounds into the approach corridor, creating a cone of fire that the fighter had to penetrate. Luftwaffe combat reports documented the deadly effectiveness of this defensive arrangement, with numerous fighters damaged or destroyed during tail attacks. Fighter pilots who survived attacks on B-7 formations described the experience as flying into a storm of traces, a visual metaphor that captured the psychological impact of facing mass defensive fire. At typical combat ranges of 400 to 800 yards, 1 in every 4 or 5 rounds loaded in American machine gun belts was a tracer, creating visible streams of fire that seemed to fill the sky around attacking fighters. These tracers, while intended primarily to help gunners adjust their aim by showing bullet trajectory, also provided an immense psychological deterrent to attacking pilots. German pilots saw walls of fire converging on their aircraft from multiple bombers simultaneously and instinctively broke off attacks before reaching optimal firing position. This psychological impact reduced German fighter effectiveness significantly, even when the actual hit probability remained relatively low due to the difficulties of deflection shooting at high closing speeds. Attacking from below presented different challenges, but no better prospects for the attacking fighter. The belly turret, called the Sperry Ball turret by Americans, provided complete coverage of the lower hemisphere with no blind spots. This remarkable piece of engineering positioned a gunner in a rotating sphere equipped with 250 caliber machine guns and a computing gun sight that helped calculate the lead angle needed to hit fast-moving targets. The ball turret gunner, crouched in impossibly cramped quarters with knees drawn up to his chest and oxygen mask pressed against the optical sight, could track targets through 360 degrees of azimuth and nearly 90 degrees of elevation from horizontal to nearly straight down. The physical demands were severe, as the position was too small for a parachute, too cramped for much movement, and required the gunner to remain curled in a fetal position for hours during long missions. But the defensive capability was unmatched. No angle of approach from below escaped the ball turret's field-off fire. German pilots quickly learned through bitter experience that attacking from beneath a B-7 formation meant exposing themselves to concentrated fire from multiple ball turrets, each one tracking their approach with mechanical precision and opening fire at maximum effective range. Side attacks faced the waist gunners positioned in open windows along the fuselage, where they endured temperatures far below zero at altitude. Hurricane force winds from the open windows and constant engine noise that made communication difficult. The B-7F featured staggered waist gun positions that prevented gunners from interfering with each other's movement while maximizing coverage angles. One gunner stood slightly forward on the port side, the other slightly after on the starboard side. Each manned a .050 caliber machine gun mounted on a flexible ring that allowed wide traverse in azimuth and elevation. Attacking from beam angles meant flying through crossfire from both waist positions plus the dorsal turret, which could rotate to engage targets anywhere above the horizontal plane. The interlocking fields of fire created zones where multiple guns could engage a single target simultaneously, concentrating fire in a way that dramatically increased hit probability. This concentrated firepower forced German fighters to make high-speed, slashing attacks rather than sustained gun runs, limiting their time on target and reducing accuracy. The tactic that emerged from Recline's test program, ACE offering the best chance of success, involved frontal attacks, approaching the bomber head-on from 12 tower high. This approach minimized exposure time to defensive fire and targeted the bomber's weakest defensive zone, where fewer guns could be brought to bear. Early B-17 models, including the F variant that Wolfhound represented, mounted only 2 or 3 flexible guns in the nose, operated by the bombardier and navigator, who had other primary duties during combat and weren't dedicated gunners. These flexible guns, mounted in sockets in the plexiglass nose glazing, had limited traverse and required the crew members to move the guns physically from one position to another. The nose glazing provided the bombardier an excellent view for accurate bombing through the Norden bomb site, but offered minimal protection for the crew members stationed there and limited the defensive firepower that could be brought to bear against frontal attacks. A German fighter pilot with nerve and skill could bore in from 12 tower high, diving slightly from above and ahead, fire a concentrated burst at the cockpit and forward fuselage where the pilot sat, then break away under the bomber before defensive guns could track him effectively. This frontal attack doctrine was pioneered by Hedman Egonmere of Jägerschard II in late 1942, Shortly before Wolfhound was captured, Mayer recognized through combat experience and tactical analysis that most B-17 defensive firepower faced rearward or to the sides, leaving the nose relatively vulnerable. Attacking from directly ahead meant the fighter's relative closing speed exceeded 500 Mach, with the fighter approaching at 350 to 400 mph and the bomber flying toward it at 150 to 180 mph. This combined closure rate gave the bomber's nose gunner perhaps 2 seconds to aim and fire before the fighter flashed past overhead or underneath. Those 2 seconds demanded extraordinary marksmanship from the defensive gunner, who had to track a rapidly approaching target, estimate lead angle, and fire accurately despite wind blast vibration, and the psychological pressure of watching a fighter dive directly toward him with guns blazing. The attacking pilot, meanwhile, enjoyed a nearly stationary target growing larger in his gun sight, making aim calculation relatively simple compared to deflection shots against crossing targets. The tactic worked spectacularly when executed properly by skilled pilots with strong nerves. German pilots who mastered the head-on pass achieved impressive kill ratios, sometimes downing multiple bombers in a single mission. But the attack demanded exceptional nerve and discipline that not all pilots possessed. Fighter and bomber hurtled toward each other at combined speeds exceeding 500 mph, closing the distance between them at nearly 750 ft/s. The attacking pilot needed to hold his course directly into the bomber's nose, watching it grow from a distant speck to a massive 4-engine aircraft filling his windscreen, waiting until the range closed to point-blank distance of 200 yd or less before firing his cannons and machine guns. Any hesitation, any early breakaway prompted by survival instinct reduced effectiveness dramatically by wasting the limited ammunition carried by German fighters. The psychological pressure of watching a 4-engine bomber grow larger in the windscreen while tracer fire from the nose guns flashed past the canopy proved too much for many pilots. They broke off too early, wasting their attack and exposing themselves to fire from the top turret as they passed overhead. Even successful frontal attacks often proved fatal for the German pilot despite destroying the bomber. The combined closing speed meant collision remained a constant danger that required precise timing and spatial judgment. Pilots who pressed their attacks too aggressively, fixating on their target and forgetting to break away in time, sometimes couldn't pull out before their fighter struck the bomber they were attacking. Multiple Luftwaffe fighters collided with B-7s during frontal passes, killing both crews instantly in the violent impact. Additionally, the massive bomber could absorb tremendous damage to its forward fuselage and still fly, demonstrating the rugged construction that gave the B-7 its reputation for toughness. Unless the attacking fighter cannon shells struck the cockpit directly, killing or incapacitating both pilots or disabled multiple engines simultaneously, the Fortress often continued toward its target despite serious damage to the nose section. German fighter pilots needed to destroy the bomber quickly and completely because wounded B-17s kept flying, kept fighting, and often made it home to England, where American repair facilities could rebuild them for future missions. A damaged bomber that returned to base represented a failed interception, despite the risk taken by the attacking pilot. These test flights at Recklen, combined with combat experience reports collected from frontline fighter units across Germany and occupied Europe, led to a comprehensive understanding of B-17 capabilities that circulated throughout the Luftwaffe in the form of tactical bulletins, training films, and intelligence reports. But this knowledge brought little comfort to German military planners who understood the strategic implications. Understanding the enemy's strengths didn't eliminate them, and the Americans kept building more fortresses faster than the Luftwaffe could shoot them down. Between May and early June 1943, Wolfhound underwent additional testing in Department E3 under Otto Kuno's direction. Engine performance evaluation measured power output at various altitudes. Supercharger efficiency analysis determined optimal operating parameters. Fuel consumption mapping created charts showing range under different conditions, all designed to understand the Wright Cyclone R1820 radial engines that powered the Fortress. Each engine produced 200 horsepower at rated altitude, and the bomber carried 4 of them in Nell suspended below and ahead of the wings. A total available power of 4,800 horsepower drove the 30-ton aircraft to speeds approaching 300 mph at altitude and operating ceilings above 35,000 ft, where the air became too thin for effective German fighter operations without specialized equipment. German intelligence analysts calculated that Boeing and its subcontractors were producing these complex aircraft at rates exceeding German heavy bomber production by factors of 5 to 10. Numbers that seemed impossible yet were confirmed through multiple intelligence sources. If American industry could manufacture such sophisticated bombers in these quantities while simultaneously building fighters, tanks, ships, and transport aircraft for global operations, what hope did Germany have of matching such industrial output? The question haunted German planners who understood that modern warfare had become as much an industrial contest as a military one. On June 12, 1943, Wolfhound appeared at an exhibition held at Lürtz Airfield for Luftwaffe commanders and technical specialists. Alongside the captured B-17 sat examples of other Allied aircraft that had fallen into German hands through combat losses or forced landings. A B-24 Liberator heavy bomber showed American approaches to long-range bombing from a different design perspective. A P-47 Thunderbolt fighter demonstrated American fighter design philosophy, emphasizing ruggedness and firepower over agility. A P-51 Mustang revealed the threat posed by long-range escort fighters that would soon accompany bomber formations deep into Germany. A P-38 Lightning twin-engine fighter showed unconventional American design approaches. An Avro Lancaster represented British heavy bombing capabilities. A de Havilland Mosquito demonstrated the fast bomber concept. A Hawker Typhoon showed British ground attack capabilities, and various Spitfire variants illustrated British fighter evolution. The display served multiple purposes beyond simple aircraft recognition training. It familiarized German personnel with enemy aircraft appearance, markings, and identification features to prevent friendly fire incidents. It demonstrated captured technology that German engineers might adapt or counter, and it provided sobering evidence of Allied industrial capacity and technical sophistication that was beginning to outpace German development in numerous areas. Luftwaffe officers who attended the exhibition came away deeply troubled by what they saw. One participant later wrote that the contrast between German and American manufacturing quality became immediately apparent even to casual observers. American aircraft components fit together with precision, tolerances that German craftsmen admired. Matching construction quality across thousands of aircraft indicated sophisticated quality control. Smooth finishes reflected attention to aerodynamic detail. Careful assembly showed systematic production methods rather than improvisation. German aircraft, produced increasingly, with slave labor under constant Allied bombing, that disrupted supply chains and destroyed tooling, showed rough workmanship. Mismatched panels requiring hand-fitting and improvised repairs using non-standard materials. The implication was unmistakable even to officers with limited technical knowledge. German industry was struggling to maintain production of increasingly obsolescent designs, while American factories turned out superior equipment in overwhelming quantities. After its appearance at the Les exhibition, Wolfhound returned to Wien for one final test program before transfer to operational service in July 1943. Engineers equipped the bomber with glider towing apparatus to evaluate its suitability for transport operations. The DFS-230 combat glider program required powerful tow aircraft capable of hauling the loaded gliders to operational altitude, and the B-7's 4 engines provided ample power for this demanding mission. Test flights between June 16th and early August evaluated towing procedures, release mechanisms, and formation flying with gliders in trail. The tests proved successful from a technical standpoint, demonstrating the B-7's versatility beyond its primary bombing role and its suitability for transport missions. But Germany's glider forces were in decline after catastrophic losses during airborne operations in Cree, where students paratroopers suffered 50% casualties, and in other theaters where airborne operations proved costly. The practical application of these towing tests remained limited as Germany lacked the transport aircraft, fleet, and fuel reserves needed for major airborne operations in 1943 and beyond. In September 1943, Wolfhound transferred to a new assignment that would take it from the test facilities at Reckland to operational service with one of the Luftwaffe's most secretive units. Kampfgeschwader Hund operated from Rangdorf Airfield near Berlin as a special operations wing unlike any other in the German Air Force. KG-200's mission portfolio included long-range reconnaissance flights deep into enemy territory using aircraft that could blend with enemy formations, insertion and extraction of intelligence agents behind Allied lines, Supply drops to German forces operating in partisan-controlled areas or cut off by enemy advances, and testing of experimental aircraft and weapons too sensitive for standard evaluation units. The unit operated an eclectic collection of German and captured Allied aircraft selected for specific mission requirements rather than standardized logistics. Alongside German types like the Weiners, D-296 engine long-range transport Heinkel 111, medium bomber and a Rad-230U transport KG-200, flew captured Soviet aircraft for operations on the Eastern Front and multiple American bombers for operations in the Western and Mediterranean. The B-17's long range exceeding 2,000 ME, high altitude capability above 25,000 FT, and rugged construction that could survive damage and harsh conditions made it ideal for many of the unit's missions. Flying captured American bombers deep into Allied-controlled territory offered unique advantages that justified the logistical burden of maintaining non-standard aircraft at night or in poor visibility conditions. Allied radar operators and fighter controllers might mistake the German crewed fortress for a friendly bomber returning from a mission over Europe, allowing the intruder to penetrate Allied airspace undetected or unchallenged. The deception could buy precious minutes or even hours before defenses reacted, time that could mean the difference between mission success and failure. Even in daylight, a B-7 flying at high altitude could potentially join American formations for short periods, gathering intelligence on tactics, formations, and radio procedures. At Rangdorf, Wolfhound received a new paint scheme designed for night operations over Allied territory. Dark camouflage colors in blues and grays replaced the earlier test aircraft schemes of yellow undersurfaces and mottled greens. KG-200 side codes beginning with A3+ were applied to both sides of the fuselage, identifying the aircraft to German forces while maintaining some operational security about its specific unit assignment. Records indicate the bomber was eventually coded A3+AE, though some sources suggest it may have carried multiple codes during its service depending on mission requirements. Detailed documentation of Wolfhound's operational service with KG-200 has been lost to history, scattered across archives that were destroyed or dispersed, concealed by participants who survived into the post-war era when certain operations remained classified for decades or simply never created due to the secretive nature of special operations work. However, post-war research by aviation historians established that KG-200 operated at least 4 captured B-7s between late 1943 and mid-1944. With some sources suggesting the number may have been higher during peak operations. These bombers flew missions across Europe, the Mediterranean, the Middle East, and North Africa, operating in some of the war's most sensitive theaters. Some missions involved straightforward transport of critical personnel or equipment to isolated German garrisons, cut off by Allied advances or operating behind enemy lines. Others inserted intelligence agents into Allied-controlled territory, using parachute drops at night or high-altitude bailouts that allowed agents to land far from the drop aircraft's apparent course. Several missions conducted reconnaissance of Allied installations, photographing ports where invasion forces might assemble, airfields where bomber forces concentrated, and supply concentrations that might indicate future Allied operations. The most sensitive operations remain shrouded in secrecy decades after the war's conclusion, their details known only to the participants who have since passed away. Hans Vera flew other captured B-7s that made their way to Rechlin after Wolfhound transferred to operational service with KG-200. On October 9, 1943, B-17F serial number 4230336, named Miss Nonley II by its American crew, crash-landed in a field at Norholm Estate near VA in Denmark after developing engine trouble during a mission over Germany. The crew bailed out over Denmark, but the pilot successfully brought the aircraft down intact in a controlled crash landing, demonstrating the B-17's docile handling even in emergencies. German recovery teams arrived quickly, understanding the value of captured American bombers, and Leers himself flew the bomber out of the field to Esbjerg Airfield, then onto Rechlin for evaluation. The fact that Lurzer could fly an unfamiliar American bomber out of a farm field with no instruction manual, no checkout flight, and no ground training spoke volumes about both his exceptional skill as a test pilot and the B-7's docile handling characteristics that made it forgiving of pilot errors. Miss Non, too, received the German code 7+8 and served in evaluation roles until at least December 1944, when records indicate it was still flying test missions. Each newly captured fortress provided fresh opportunities for detailed examination. Engineers compared different production blocks, looking for evolutionary changes that might indicate vulnerabilities to exploit or improvements that required new German countermeasures. They tested various ammunition types against B-7 structure to determine optimal attack profiles for fighter pilots. They evaluated the effectiveness of different German cannon calibers against American armor and self-sealing fuel tanks, finding that their 20mm cannons were marginally effective, while 30mm cannons proved devastating when hits were achieved. What emerged from these exhaustive tests was a comprehensive picture of an aircraft that represented the peak of American bomber development in 1943, and a level of defensive firepower that had fundamentally altered the calculus of daylight strategic bombing. Consider the statistics that German test pilots calculated at recline. A single B-17G, the final and most heavily armed variant that would enter service in summer 1943, carried 13 Browning M2 machine guns of 50 caliber, positioned to provide complete defensive coverage. These weapons fired standard 0.50 BM ammunition at 750 to 800 rounds per minute, with each gun capable of maintaining sustained fire for several minutes at a time, limited only by ammunition capacity and barrel heat buildup that required careful management by gunners. The typical ammunition load for a B-7G totaled approximately 7,500 rounds distributed across all gun positions. According to a carefully calculated scheme that balanced defensive coverage with weight considerations, this provided each gun position with hundreds of rounds available for defensive engagement during the long missions over Europe. The tail turret alone carried 500 rounds per gun, for 1,000 rounds total, sufficient for sustained engagement of pursuing fighters. The dorsal turret held similar quantities to allow the top turret gunner to engage targets over an extended period. The ball turret, despite severe space constraints in the cramped sphere, carried 250 to 500 rounds per gun, depending on mission requirements and the gunner's size. The waist positions each had 600 to 800 rounds for their flexible guns. The nose positions, including the chin turret on G models, held similar loads calculated to provide adequate ammunition for the entire mission. When German test pilots at Reclan calculated the combined firepower of a single B-17G firing all guns simultaneously at a target, the numbers proved staggering and explained why bomber crews had such confidence in their defensive capabilities. Guns at 750 rounds per minute each produced a combined rate of fire approaching 10,000 rounds per minute across all positions. Translated to rounds per second to better understand the immediate tactical effect. A fully engaged fortress could throw approximately 160 heavy machine gun bullets into the surrounding airspace every second, creating a cone of fire that filled the approach corridor with lethal projectiles. But American bombers never flew alone over enemy territory. The entire concept of American daylight strategic bombing developed through pre-war doctrine and refined through painful combat experience in 1942 and 1943. Relied on masked formations where multiple bombers provided mutual defensive fire that dramatically increased the firepower any single attacking fighter would face. The combat box formation developed by Colonel Curtis LeMay and refined through bloody experience over Germany positioned bombers in tight three-dimensional arrays where each aircraft's guns could support its neighbors. A squadron element typically contained 3 aircraft flying in close formation, a V or echelon depending on tactical situation. 3 squadron elements stacked vertically and offset horizontally formed a squadron box of 9 bombers. 3 squadron boxes formed a group box of 27 aircraft, though some groups flew with 4 squadrons for a total of 36 bombers. A typical 3-squadron group box contained 18 to 27 aircraft depending on attrition and maintenance status. If each bomber carried even 9 guns instead of 13, assuming a mix of Fan G models in the formation, the group's combined defensive armament exceeded 180 heavy machine guns providing interlocking fire. 3 such groups combined to form a wing box with 54 to 81 bombers and 500 to 700 machine guns providing interlocking defensive fire that created zones where attacking fighters faced concentrated fire from dozens of bombers simultaneously. German fighter pilots attacking such formations described approaching a wall of tracers, a vivid description that captured the visual and psychological impact of mass defensive fire. At typical combat ranges of 400 to 800 YD, every bomber gunner who detected an attacking fighter opened fire simultaneously, creating a visual spectacle that was both beautiful and terrifying. 50 or more machine guns might concentrate fire on a single fighter, making a head-on pass through the formation, with each bomber's gunners tracking the target and firing at maximum rate. The psychological impact overwhelmed many pilots regardless of actual hit probability, which remained relatively low due to the difficulties of deflection shooting, range estimation, and the brief time available for engagement. Luftwaffe after-action reports documented numerous instances of fighters breaking off attacks prematurely before reaching optimal firing range because pilots couldn't force themselves to fly deeper into the defensive barrage. Those pilots who maintained formation discipline and pressed attacks home despite the defensive fire faced brutal arithmetic that favored the defenders. Luftwaffe studies conducted using data from actual combat engagements determined that rear attacks on B-7s required an average of 20 hits from 20mm cannon shells to destroy a bomber. And that figure assumed hits were distributed across vulnerable systems rather than concentrated in one area. The B-17's rugged construction, redundant systems, and self-sealing fuel tanks allowed it to absorb tremendous punishment and continue flying. Average pilot accuracy against evasive targets at combat ranges ran approximately 2%, a figure determined through analysis of gun camera footage and ammunition expenditure reports. Therefore, bringing down a single fortress from behind required firing approximately 1,000 rounds of 20mm ammunition to achieve the 20 hits needed for a kill. Early model Fowler-Wolf FW-190 fighters carried only 500 rounds total of 20mm ammunition, distributed across 2 cannons, with each gun holding 250 rounds in drum. Magazines upgrading to 4 cannons with belt-fed ammunition provided only 500 to 600 total rounds across all guns, still insufficient for multiple attack runs. Even with upgraded armament, a German fighter pilot might have ammunition for 1, perhaps 2 sustained gun runs before running Winchester and being forced to break off and return to base for rearming. Meanwhile, the bombers continued firing as long as they detected threats, their thousands of rounds of .050 caliber ammunition allowing prolonged defensive engagement throughout the mission, while individual bomber gunners achieved relatively low hit percentages due to difficult deflection shooting at extreme ranges and high closure speeds. The sheer volume of fire made hits statistically inevitable when dozens of bombers engaged a single target. Luftwaffe fighter losses climbed steadily through 1943. American bomber streams grew larger and more frequent while German fighter forces struggled to regenerate losses faster than combat attrition and training accidents destroyed them. Front attacks offered better kill ratios for skilled pilots, but demanded extraordinary skill and courage that not all pilots possessed. Approaching head-on meant the fighter closed at combined speeds exceeding 500 km/h, with both aircraft moving toward each other at maximum speed. At that closure rate, the target picture changed dramatically every second, requiring constant attention and rapid decision-making. Range estimation became critical to attack success as opening fire too early meant rounds dissipated without effect while waiting. Too long made collision unavoidable. The optimal firing envelope lasted perhaps 2 seconds from 400 YD to 100 YD, a brief window requiring precise timing. During those 2 seconds, the fighter pilot needed to aim carefully while compensating for his own aircraft's motion. Compensate for the bomber's evasive maneuvers, which might include slight turns or altitude changes, fire multiple bursts while correcting aim between bursts, and initiate the breakaway maneuver before the aircraft collided. This demanded constant practice under realistic conditions and exceptional reflexes that only experienced pilots developed. The captured B-17 at Woolleen allowed German fighter pilots to study their target intimately in ways impossible through combat experience alone. They walked completely around the fortress, examining it from every angle and noting the gun positions and their fields of fire. They climbed inside through the waist windows and crawled through the cramped interior, experiencing the limited space and difficult working conditions that bomber gunners endured. They sat in the various gun positions, including the ball turret, testing traverse and elevation limits, while noting the blind spots where attacking fighters might evade defensive fire if they approached from specific angles. They flew formation exercises where the bomber took evasive action, while fighters practiced approach angles and firing solutions, creating training scenarios that transferred to combat. This training proved invaluable for experienced pilots who learned to exploit the B-7's vulnerabilities through systematic study. But by late 1943, the Luftwaffe was losing experienced Pilots faster than training programs could replace them with equally skilled aviators. New pilots straight from flight school lacked the hundreds of hours of experience needed to execute complex attack maneuvers under fire while maintaining situational awareness. They often broke off attacks prematurely or pressed them too aggressively, either wasting their ammunition or dying in collisions. Additionally, the Americans continuously improved their bombers based on combat experience and crew feedback. The B-17G model entering service in late summer and fall 1943 added the distinctive chin turret under the nose, a remotely operated turret mounting 250 caliber machine guns that could engage targets directly ahead. This remotely operated turret was controlled by the bombardier through a computing gun sight, significantly improving the bomber's frontal defensive capability against the head-on attacks that had proved so effective against earlier models. Suddenly, the head-on attack that had been the preferred tactic of German aces became far more dangerous for attacking pilots. The chin turret could track an attacking fighter throughout its approach from first detection at long range, concentrating fire along the predicted intercept path. Combined with the existing cheek guns operated by the bombardier and navigator, plus the top turret, which could swing forward to add its 2 guns to the defensive barrage, a B-17G could bring 6 to 8 heavy machine guns to bear on a frontal attacker, creating a defensive cone that required exceptional skill to penetrate. This forced the Luftwaffe to adapt once again, searching for new tactical solutions to the evolving defensive problem. Fighters began attacking from high angles, diving from above and ahead at steep angles where the bombers' gunshad limited elevation traverse due to mechanical limits. Others approached from below the nose, hoping to stay under the chin turret's depression limits while avoiding the ball turret. Still others resorted to standoff weapons, launching unguided rockets from beyond machine gun, effective range and hoping for lucky hits on the tightly packed formations where even near misses might cause collision damage. The Ware Granite 21-centimeter rocket became a favored weapon among German fighter units launched from tubular launchers mounted under the wings. These unguided projectiles carried large, high explosive warheads intended to break up bomber formations through blast effect rather than achieve direct hits. Actual hit probability remained low due to the rocket's poor ballistic characteristics, but a rocket exploding in the midst of a combat box could damage multiple bombers simultaneously through blast and fragmentation, or cause collisions as pilots took violent evasive action. But standoff attacks carried their own serious problems that limited their effectiveness. The rockets were inaccurate beyond 800 YD, heavy enough to significantly reduce fighter performance, and created substantial drag that made the launching fighter vulnerable to Allied escort fighters. Pilots carrying underwing rocket tubes became easy targets for American P-51 Mustangs and P-47 Thunderbolts, which by 1944 included long-range variants capable of accompanying bomber formations all the way to Berlin and back, eliminating the sanctuary that German fighters had previously enjoyed in the depths of German airspace. The technological race continued throughout 1943 and 1944 as both sides sought advantages. The Luftwaffe developed heavier cannons including 30mm Mk-108s that could destroy bombers with a few hits, larger rockets with improved guidance, and even experiments with aerial bombing where fighters dropped small bombs onto bomber formations from above. The Americans improved defensive armament with the G model, perfected formation tactics through painful experience, and introduced better escort fighters with longer range and improved performance. But one inescapable reality dominated this equation that no amount of tactical innovation could change. American industry could replace losses faster than German industry, despite operating on the far side of the Atlantic Ocean and shipping everything to Europe. Every B-17 shot down over Europe represented a tactical victory for the Luftwaffe pilot who achieved the kill, but only a strategic victory if it prevented future missions. But within weeks, sometimes mere days, another brand new fortress, fresh from Boeing's production lines in Seattle, from Douglas plants in Long Beach, or from Vega facilities in Burbank, would replace the lost bomber, arriving in England with a fresh crew ready to continue the bombing campaign. Production statistics told a story of overwhelming material advantage that German intelligence analysts understood, but could do nothing to counter. Boeing, Douglas, and Vega built 12,731 B-17 bombers between 1935 and 1945, with the overwhelming majority produced during the peak war years of 1943 and 1945, 1944. Boeing's Seattle plant alone built 681 B-17s across all variants. Douglas contributed 3,000 from plants in Long Beach, California. Vega, a Lockheed subsidiary, added 2,750 from Burbank, California. Peak production in 1944 saw Boeing alone building approximately 362 B-17 bombers per month, more than 12 per day from a single manufacturing facility, a rate that seemed impossible to German observers, but was verified through multiple intelligence sources. German four-engine bomber production never approached these figures, despite having a more advanced aviation industry at the war's start. The Henkel Her 177, Germany's only operational Freien heavy bomber and the result of years of development, suffered from chronic engine fires due to its unusual coupled engine design and mechanical problems that limited operational availability. Total production across all variants barely exceeded 100 aircraft between 1942 and 1944, and operational availability remained so poor that many units refused to accept the type, preferring twin-engine medium bombers despite their inferior range and bomb load. Germany simply couldn't match American heavy bomber production in either quantity or quality, a failure rooted in strategic decisions, industrial organization, and resource limitations. When Luftwaffe pilots learned these production statistics through intelligence briefings that attempted to prepare them for the scale of opposition they would face, morale suffered accordingly among thoughtful pilots who understood the implications. What was the point of risking their lives to shoot down one fortress when 10 more would replace it within a week? The question haunted fighter squadrons across Germany. As the strategic situation deteriorated through 1944, the captured B-17 at Reclan provided German engineers with detailed understanding of American manufacturing methods that explained how such production rates were achieved. They studied the modular construction that allowed sub-assemblies built at different factories across the United States to fit together perfectly during final assembly with minimal hand-fitting. They examined the standardized components sourced from hundreds of subcontractors nationwide, creating a supply chain of unprecedented complexity and efficiency. They analyzed the simplified assembly sequences that allowed semi-skilled workers, many of them women entering industrial work for the first time, to build complex bombers in a fraction of the time experienced German craftsmen required using traditional methods. German reports from these studies expressed grudging admiration for American industrial organization, while noting the impossibility of Germany matching such methods. The B-17 represented more than individual engineering excellence or clever design solutions. It represented a complete manufacturing philosophy, prioritizing production volume over artisanal quality, emphasizing interchangeable parts over custom fitting, and accepting adequate quality over perfection. Every design decision reflected this philosophy of mass production. Standardized fasteners throughout the aircraft reduced inventory requirements and simplified assembly. Straight panels with minimal compound curves simplified forming operations and reduced scrap rates. Modular subassemblies allowed parallel construction of fuselage sections, wings and tail surfaces that came together in final assembly with minimal fitting required, dramatically reducing production time. This approach enabled Boeing's Seattle plant to complete one B-17 every hour at peak production rates, a feat that seemed impossible to German observers accustomed to production rates measured in weeks per aircraft. German factories still using traditional aircraft construction methods with custom-fitted components, hand-riveted assemblies, and skilled craftsmen performing most operations required weeks to build a single bomber. The implications were strategic and inescapable to anyone who understood industrial production. Even if German fighters achieved favorable loss ratios in combat, even if they shot down 2 or 3 bombers for every fighter lost, American industry could sustain such attrition indefinitely, while German industry could not. By mid-1944, this reality became undeniable, even to the most optimistic German commanders. The question was no longer whether Germany could win the air war over Europe. The question became how long German forces could continue fighting against increasingly overwhelming material disadvantage before collapse became inevitable. Wolfhound and the other captured B-7s at Reclan had taught the Luftwaffe everything they needed to know about the Flying Fortress as a weapons system. They understood its strengths, including its rugged construction and heavy defensive armament. They knew its weaknesses, including the vulnerable nose on early models and the blind spots in gun coverage. They had documented its capabilities in terms of range, altitude, bomb load, and formation flying. They understood its limitations, including the need for formation integrity and vulnerability to determined frontal attacks. They developed tactics that, when executed properly by skilled pilots with strong nerves, could destroy the bombers despite their defensive firepower. But this knowledge couldn't change the fundamental arithmetic of industrial production that determined strategic outcomes. For every German pilot who learned to attack B-7s effectively through training at recline or through combat experience, the Americans trained 10 new bomber crews. For every fortress shot down over Germany through superior German tactics, American factories built 5 more bombers. For every successful interception that disrupted a bombing raid, a dozen more raids flew the next week with even larger formations. The defensive firepower that so impressed German test pilots represented only one aspect of a comprehensive system designed to project American strategic bombing capability deep into enemy territory despite determined opposition. The B-7 combined long range exceeding 2,000 mm, high altitude capability above 25,000 ft, heavy bomb load of 4,000 to 8,000 lb depending on mission requirements, rugged construction that could absorb battle damage, and devastating defensive armament into a single package that, when multiplied across hundreds of aircraft flying and mutually supporting formations, created an aerial weapon that fundamentally changed the nature of warfare. Luftwaffe General Adolf Galland, one of Germany's most successful fighter aces with 104 confirmed victories and eventual commander of German fighter forces, wrote extensively in post-war years about the challenges of defending against American daylight bombing. He acknowledged that individual German pilots often possessed superior training and more extensive combat experience compared to American bomber crews, many of whom were on their first combat tour. German fighters, particularly late war models like the Fowler-Wolf FW-190D9 long-nose variant and Messerschmitt Bf-109K4, could outperform B-7s in every performance metric, including speed, climb rate, and maneuverability. German cannons hit far harder than American 50 caliber machine guns, delivering explosive shells that could destroy bombers with a few hits. Yet, despite these advantages in equipment and pilot skill, German fighters couldn't stop the daylight bombing campaign that systematically destroyed German industrial capacity. Galland attributed this failure to multiple factors in his post-war writings and interviews. But American industrial capacity topped his list of decisive factors. The Americans simply built more of everything faster than Germany could destroy it, whether bombers, fighters, tanks, or any other war material. The captured B-17s proved this reality beyond any doubt for German engineers and planners who studied them. German engineers dismantled every system, studied every component, evaluated every design decision with thoroughness that would impress any technical investigator. They found much to admire in the bomber's design and little to criticize from an engineering perspective. The Fortress represented mature engineering executed with manufacturing excellence that integrated the best available technologies into a coherent weapons system. No amount of tactical innovation or pilot skill could compensate for such material disparity in a war of attrition. Hans Vera Leers flew numerous captured aircraft during his tenure at Recline and other test facilities, accumulating over 125 different aircraft types from various nations without a single serious accident that damaged an aircraft or injured the pilot. His post-war writing reflected professional respect for Allied aviation technology, tempered by frustration at German industry's inability to match Allied production rates and organizational efficiency. He flew B-17s, B-24 Liberators, British Lancasters, Soviet P-2s, and numerous fighter types from all combatant nations. Each aircraft taught specific lessons about Allied capabilities and different national approaches to aviation design philosophy. But the B-7 remained the most strategically significant aircraft he evaluated because it represented American strategic bombing doctrine made manifest in aluminum and steel. Every aspect of the Fortress's design supported its mission to penetrate deep into enemy territory, deliver heavy bomb loads with precision using the Norden bomb sight, and return home despite determined opposition from fighters and anti-aircraft artillery. The defensive armament that so impressed German evaluators served as the critical enabler for this mission profile. Without those machine guns and the interlocking defensive formations they made possible, daylight strategic bombing would have proven impossible. Regardless of how many bombers the Americans built, German fighters would have slaughtered unescorted bombers in numbers that would have forced the Americans to abandon daylight operations and switch to night bombing like the British, reducing accuracy and effectiveness. The B-17's defensive firepower, didn't make the bombers invulnerable to attack or prevent losses. Thousands were shot down over Europe by determined German fighter pilots and accurate anti-aircraft fire, but the defensive armament made them survivable in sufficient numbers to accomplish their mission over time. Enough bombers got through the defenses to hit their targets. Enough crews survived their tour of 25, then later 35 missions to return home and train new crews. The cumulative effect of hundreds of bombing missions over 2 years systematically destroyed Germany's industrial capacity, oil production facilities, transportation networks, and military production capabilities. By 1945, when Wolfhound met its end during an American bombing raid on Oranienburg airfield on April 10, 1945, the strategic bombing campaign had achieved its primary objectives. German industry lay in ruins across the Ruhr Valley and other industrial centers. Fuel shortages grounded much of the Luftwaffe, despite having aircraft available. Transportation chaos prevented delivery of critical supplies to front lines where German armies faced defeat. The fortresses had completed their mission despite heavy losses along the way. The captured bomber that taught the Luftwaffe so much about American defensive firepower had become a symbol of the futility of fighting against overwhelming material advantage. German pilots who learned to attack B-17s using knowledge gained from flying captured examples found themselves increasingly irrelevant as American. Bomber streams grew to include 1,000 aircraft escorted by equal numbers of long-range fighters. Individual skill and tactical excellence couldn't compensate for such numerical inferiority and industrial disparity. The story of captured B-17s in German service represents a curious footnote to the larger narrative of the strategic bombing campaign over Europe. These aircraft, built in American factories by American workers, flown by American crews on combat missions, shot down or forced down by German forces, then rebuilt and flown by German pilots, served as unique windows into Allied capabilities and American industrial methods. They revealed strengths the Luftwaffe needed to counter through new tactics and weaknesses that could be exploited by skilled pilots. They trained fighter pilots in aircraft recognition and attack procedures that saved lives. They supported special operations, missions deep behind enemy lines that achieved tactical objectives. They contributed to the German war effort in numerous ways throughout 1943 and 1944, yet ultimately they also demonstrated the impossibility of Germany's strategic position by revealing the scale of American industrial capacity. Every hour German technicians spent repairing captured American aircraft represented skilled labor diverted from maintaining German aircraft. Every gallon of precious fuel burned. Testing enemy bombers was fuel unavailable for combat operations. Every bullet fired during evaluation exercises represented ammunition Germany couldn't spare. Meanwhile, American factories produced more B-7s every day, replacing losses faster than combat could inflict them. The production statistics remain staggering even 8 decades after the war's end. Boeing's Seattle Plant 2 alone built 6,981 B-17s across all variants from the original Y-1 B-17 through the final B-17G. Douglas contributed 3,000 from plants. In Long Beach between 1942 and 1945, Vega added 2,750 from Burbank. In the same time frame, total production exceeded 12,731 aircraft by war's end, with the final B-17 delivered in May 1945. Each bomber was a complex machine, containing approximately 40,000 individual parts manufactured by hundreds of subcontractors. 4 Wright Cyclone R-1820 engines producing 200 horsepower each, miles of electrical wiring connecting systems, thousands of pounds of aluminum formed into airframe structures, and that formidable defensive armament of up to 13 heavy machine guns with thousands of rounds of ammunition. Germany never built even 2,000 Vorrhein bombers during the entire war, despite starting with a more advanced aviation industry in the 1930s and having pioneered strategic bombing concepts. The reasons for this dramatic production disparity extended far beyond simple industrial capacity or factory floor space. American strategic doctrine prioritized heavy bombers for deep penetration missions and strategic targeting, while Germany focused on medium bombers and dive bombers optimized for close air support of ground forces. A fundamental difference in military philosophy. American geography, protected by vast oceans that enemy forces couldn't cross, allowed undisturbed factory expansion and operation, while German industry operated under constant Allied bombing that destroyed facilities, killed workers, and disrupted supply chains. American engineering education produced thousands of skilled designers, managers, and technicians annually, while Germany struggled with manpower shortages as the war dragged on and casualties mounted. Most fundamentally, American political and economic systems proved more adaptable to total war mobilization than the rigid Nazi hierarchy with its competing power centers, inefficient decision-making, and ideological constraints. All these factors combined to create the industrial advantage that determined strategic outcomes. The B-17 Flying Fortress represented just one weapon in America's vast arsenal, but it symbolized the entire apparatus of American war production. When Luftwaffe officers stood before Wolfhound Ettlin, studying its construction, testing its systems, flying evaluation missions, they were really studying American industrial civilization and its capacity for sustained production. What they learned should have been obvious from the beginning to anyone who studied American industrial capacity objectively. You cannot defeat an enemy who can build bombers faster than you can shoot them down, who can train crews faster than you can kill them, who can deliver bombs in greater tonnage than your entire nation's industrial output across all sectors. The defensive firepower that so impressed German test pilots was merely the visible manifestation of deeper American advantages in industrial organization, resource allocation, and economic mobilization. The real secret weapon wasn't the 13 machine guns mounted on the B-17G. It was the economic and industrial system that could design, manufacture, and deploy 12,731 of these bombers while simultaneously building 300,000 aircraft of all types, 88,000 tanks, 41 billion rounds of ammunition, and everything else needed to fight a global war on multiple fronts across several continents and 2 major oceans. No amount of tactical brilliance, pilot skill, or individual courage could overcome such overwhelming disparity in industrial output. No wonder Hans Lecker, after flying dozens of captured Allied aircraft and seeing firsthand the quality and quantity of enemy equipment, concluded that Germany had already lost the war by 1943 based purely on industrial mathematics. The mathematics of material production predicted defeat with mathematical certainty. The only questions remaining were when the end would come, and at what final cost in lives and destruction. The captured B-17 at Lynn answered some important tactical questions for German fighter pilots. They revealed blind spots in defensive coverage that skilled pilots could exploit. They identified vulnerable systems, including hydraulics and oxygen, that could disable the bomber. They demonstrated attack profiles that offered the best chance of success for determined pilots. But they couldn't answer the fundamental strategic question that determined outcomes. How do you stop 10,000 bombers when you can barely build 1,000 fighters annually? How do you defend cities against endless raids when your pilots fly 3 or 4 missions per day until they're killed, wounded, or too exhausted to continue? How do you maintain industrial production and civilian morale when every factory worker knows American bombs will eventually find their workplace? These questions had no satisfactory answers within the framework of Nazi Germany's war strategy and industrial organization. The regime had started a war of conquest, assuming quick victory before enemies could fully mobilize their economies and industrial capacity. When that fundamental assumption proved false, when the war became a grinding contest of industrial attrition and staying power, Germany's fate was sealed by decisions made in the 1930s. The B-17 Flying Fortress, with its multiple heavy machine guns throwing 160 rounds per second into the surrounding airspace with its ability to absorb horrific damage and continue flying toward targets with its clear manifestation of American industrial capability and organizational efficiency, represented not just a tactical challenge, but a strategic verdict on the war's outcome. The bombers came every day in increasing numbers. The fighter escorts grew more numerous and capable. The targets burned systematically, and there was nothing the Luftwaffe could do to stop the campaign despite heroic individual efforts. Luftwaffe test pilots at Rechen flew captured B-7s extensively and came away with grudging respect for American engineering, manufacturing, and military organization. They admired the bomber's rugged construction that allowed it to survive damage that would destroy lesser aircraft. They appreciated its thoughtful design that prioritized crew survivability and operational effectiveness. They acknowledged its devastating defensive firepower that made attacking the formations a deadly proposition even for experienced pilots. But respect for the weapon did nothing to change the outcome of battles in the sky over Europe. Knowledge of the enemy's capabilities couldn't create the resources, needed to defeat them when those resources simply didn't exist in sufficient quantities. By late 1944, many of the captured B-17s in German service had been destroyed or rendered unfillable through various causes. Some fell victim to Allied bombing raids on German airfields as the bombing campaign targeted Luftwaffe infrastructure. Others crashed due to maintenance issues as spare parts became impossible to obtain with supply chains disrupted. A few continued flying special missions for KG-200 until the final weeks of the war in early 1945, but their intelligence value had been largely exhausted by this point. The Luftwaffe knew everything worth knowing about the flying fortress through years of study. They understood its blind spots where guns couldn't reach. They knew its vulnerabilities in specific systems. They had developed tactics to attack it effectively when conditions allowed. Yet this hard-won knowledge proved increasingly useless against the reality of 1,000 bomber raids, escorted by hundreds of fighters that overwhelmed defenses through sheer numbers. Individual German pilots continued achieving remarkable success against B-17 formations throughout the war. Some aces shot down dozens of bombers using perfected attack techniques, learned partly from studying captured examples at Reclan. But heroic individual performance couldn't compensate for systematic industrial inferiority and numerical disadvantage. For every ace who survived long enough to develop expertise through dozens of missions, 10 novice pilots died on their first or second combat mission before learning effective tactics. The average life expectancy for a German day fighter pilot by 1944 measured in weeks rather than months. Many never achieved 10 combat missions before being killed or too badly wounded to continue flying, creating a downward spiral of declining experience levels. The Americans, meanwhile, implemented systematic crew rotation policies that sent crews home after completing tour requirements of 25 missions initially. Later increased to 35 missions as loss rates declined. Survivors returned to training commands in the United States, where they passed hard-won combat experience to new crews, creating institutional learning that preserved lessons purchased with blood. This systematic approach to crew utilization contrasted sharply with German practice of flying pilots until they died, were captured, or became physically unable to continue due to wounds or exhaustion. The different philosophies reflected different industrial realities and strategic positions. America could afford to rotate experienced crews to training roles because production provided steady streams of replacement aircraft and new crews fresh from training. Germany couldn't spare anyone with combat experience. Every pilot capable off-flying combat missions stayed on the line until killed, captured, or incapacitated, leading to declining average experience levels across fighter units. Captured B-17 taught the Luftwaffe much about American defensive firepower through systematic study. The experience off-fighting against 1,000 bomber raids taught harder lessons about American resolve, resources, and industrial staying power. But the ultimate lesson came in May 1945 when the guns finally fell silent across Europe. Germany lay in ruins, its cities destroyed, its industry shattered beyond immediate repair, its military crushed between Soviet forces in the east and Western Allied armies in the west. The bombers had done their work over 2 years of sustained operations. The defensive firepower that so impressed German test pilots in 1943 had proved sufficient for the fortresses to complete their mission despite taking terrible losses along the way, with nearly 5,000 B-7s lost to all causes during the war. The story ends where it began, in the sky over Europe, where men fought and died in machines that represented their nation's industrial capabilities, strategic doctrines, and approaches to warfare. Hans Voss survived the war and lived until 1991, long enough to publish his memoirs and participate in numerous historical projects, documenting Luftwaffe test pilot experiences for future generations. He remained proud of his service and technical accomplishments, while acknowledging the futility of Germany's cause and the inevitability of defeat once American industrial capacity fully mobilized. His expertise flying captured Allied aircraft made him valuable to Allied intelligence services after the war, and he contributed to several projects evaluating German and captured Allied aircraft for post-war air forces. Wolfhound, the first intact B-7 captured by the Luftwaffe, served Germany from December 1942 until its destruction in April 1945. During those 2.5 years, it taught German aviators and engineers volumes about American bomber design, defensive tactics, and industrial capabilities. The lessons proved intellectually valuable, but strategically irrelevant to changing outcomes. Understanding your enemy's advantages doesn't eliminate them or create counters when the resources don't exist. The 13 machine guns that so impressed test pilots at Recline represented not just defensive armament, but American industrial philosophy made tangible in metal. Overwhelming firepower through volume of fire, mutual support through formation tactics, redundancy through multiple weapon systems covering all approaches, all designed to ensure that enough bombers survived each mission to destroy their targets and return home to fly again. This philosophy worked despite heavy costs, despite losing nearly 5,000 B-7s to all causes during the war, including combat losses, operational accidents, and weather. Despite casualty rates among bomber crews that exceeded 20% in some units during 1943, despite German fighter opposition that shot down hundreds of fortresses in determined resistance, the strategic bombing campaign succeeded in its objectives. Germany's war industries were destroyed across the Ruhr and other centers. Its cities burned from incendiary attacks. Its transportation networks collapsed under sustained interdiction. And when the war ended, American factories were still building B-17 at rates that would have allowed complete replacement of all combat losses within 6 months, demonstrating the ultimate futility of trying to win a nutrition war against American industrial capacity. The captured B-17s in German service became unwitting witnesses to their own nation's defeat. Every test flight revealed American capabilities. Every evaluation report documented American advantages. Every training exercise emphasized the same inescapable message. America possessed industrial capacity that Germany could never match through any realistic means. The defensive firepower was impressive and merited respect. The productive capacity behind it was overwhelming and ultimately decisive. That was the real lesson of the captured flying fortresses, though it took time for all participants to fully comprehend the implications. The Luftwaffe officers who flew captured B-7s admitted they had never seen defensive firepower like it in their experience with other bomber types. They marveled at the interlocking fields of fire that covered all approach angles, the heavy caliber weapons that could destroy fighters at long range, the volume of ammunition that allowed sustained engagement. But the defensive guns were merely the visible manifestation of America's true weapon, the arsenal of democracy operating at full capacity and coordination. That arsenal, once unleashed and fully mobilized, proved unstoppable despite a determined resistance. The fortresses came in their hundreds, the bombs fell on their targets, and Germany fell with them. The captured B-7s could teach tactics and reveal vulnerabilities. They couldn't change the strategic destiny determined by industrial capacity.